Hey, good afternoon, students. This is a video for 2-7. I had intended to put it on later, but there was a problem with the video. I had to completely start over. So let's go ahead. All right. Let me just try to set this so that everything is where I want it to be. Okay. All right. Lesson 2-7 on page 136 is on proportions. Proportion is any set of two or more ratios that are equal or equivalent. A proportion is any set of two or more ratios that are equal or equivalent. Now I have our proportion right here. 4/10 is equal to 2/5. Now you notice that I pointed my arrow here to this entire box. This entire thing, these two ratios, or this pair of ratios, is a proportion. It's not one ratio or the other. 4/10 is not a proportion, and 2/5 is not a proportion. Together they make a proportion. And I pointed out here that both of these are ratios. You may remember in the last lesson I did mention something about if there's 12 students at like 4 tables, then that means that there would be 3 students at 1 table, okay? Let me go ahead and write that. 12 to 4 is equal to 3 to 1. Now, in a sense, all I've done was taken my first ratio here and I reduced it to a lower ratio, okay? So 12 students and 4 tables tells me how many kids there are in the class and how many tables there are. Assuming that they are sat at each of those tables equally, then that means that there would be 3 students for every 1 table, or 3 students per table, okay? So in the same sense, 4/10 and 2/5 are a proportion, as 12/4 and 3/1 is a proportion. So you have to have at least 2 ratios to make a proportion, kind of like you have to have 2 shoes to make a pair, okay? Now, if you look at these, even though the numbers are not exactly the same, the ratio is the same. What do I mean by that? Well, 4 is exactly 40% of 10. 2 is exactly 40% of 5, okay? So if you look at percents, which is a later lesson, then that can be helpful in determining proportionality, or just noting that the ratio, the comparison of the two numbers is the same. 4 is the same part of 10 as 2 is to 5, okay? Now, I want to continue with the lesson. So we can use proportions in a lot of different ways to help us determine things about numbers that we need to know. One feature is the cross product property. Given 2 ratios form a proportion if one, meaning one person, multiplies the numerator of one ratio with the denominator of the other ratio and then repeats, vice versa, they will produce equal numbers. Now, here's a proportion just written with letters just to demonstrate. So if the numerator of one times the denominator of the other, A times D in this case, because I named them as A, B, C, D, are multiplied, and vice versa, B times C here are multiplied, then their answers are going to be equal, provided that the value of B and the value of D are not 0. Okay? So you can cross multiply by simply multiplying numerator, denominator, denominator and numerator, and then compare them, and the numbers should be equal if it's a proportion. So cross multiplication can help you do these 3 things. Let me just move this so it's, just want to make sure you can see what I need you to see here. It can help you to determine equality. It can help you to find the missing part of a proportion, provided that you know that everything is equal. And it can help you to solve multi-step problems when there's a lot of information in the numerators. Okay, let's go ahead and follow the steps. So I have two ratios here. I want to see if they form a proportion. I don't know here if they're equal because it tells me question mark. So let's try. Let's multiply numerator times denominator. 3 times 28 is 84. Now, denominator times numerator. 4 times 21 is 84. Now oh, well, look at that. They're equal. So then I can know for certain that 3/4 is equal to 21 over 28. And this is a proportion. So I ran out of room there to write the word proportion. So I'll just say yes. Okay. How can you tell? Because when I use the cross product property here, my answers were equal. Just a quick note, some of you might not have a lot of skill with arithmetic and you don't memorize your times tables. Honestly, you can use one of these during your homework or during your test. I just don't want students using phone calculators if at all possible. Let's continue with the next problem. So it can determine equality, but it can also help you find the missing part. Let's try cross multiplying this. 2 times 12 is 24. Okay, so if I cross multiply that, all right. Now, you notice in this one, there's no question mark. We know that these two ratios are equal, so they form a proportion. We already know that there's a proportion there. But that's not what we're missing. What we're missing is the value of this part of the proportion. What is x? So 8 times x, since I don't know what x is, I'm just going to go ahead and write 8x. Okay, so 24 is equal to 8x. Well, look, now I have an algebra problem. So I solve that. Isolate. Opposite. Both. Remember IOB, isolate opposite both. 24 divided by 8 is 3. So x is equal to 3, or 3 is equal to x. I like to write this in the standard format, so I'll just go ahead and change the order of my answer here. X is equal to 3. Okay, so you can use cross multiplication to create an algebra problem out of a proportion problem. Once you have the algebra problem, then just follow the steps. Isolate opposite both. Now you can also use this for multi-step problems. Now, I want to remind you, when you have an expression grouped together in a place where you normally have a single number, remember that your expression is just a single number. So b minus 8 is how many numbers? I know you're thinking it's 2 numbers because you see 2 things there. It is 1 number. It's just a number that we don't have all the information to put it together as, but it's still just 1 number. So we can cross multiply by multiplying b minus 8, which is my numerator, times 4, which is my opposite denominator. Okay, well, how do I do that? You can write this as a distributive property problem. b minus 8 times 4 is just 4 times the result of b minus 8. Now the equal sign, I'm going to go ahead and rewrite that again. I'll just bring it down here so we don't forget that. Now we're going to cross multiply the other side. 5 times b plus 3 is 5 times, remember the parentheses, the result of b plus 3. Now those parentheses are important because when you do distributive property, you multiply what's outside the parentheses to everything on the inside of the parentheses, okay? So if you had no parentheses, then you would say 5 times b, and then you would say plus 3. No, you have to multiply the 5 to everything. So now I'm going to distribute so I can simplify my problem. 4 times b is 4b. 4 times 8, 8, 16, 24, 32. And I'm going to bring down the minus sign. Just a quick note, you can say 4 times negative 8 is negative 32, or you can say 4 times 8 is 32, and then just bring down the minus. Okay? Now, let me go ahead and write equals here. I'm just bringing the equals down. Now let's multiply this. 5 times b is 5b. 5 times 3 is 15. Bring down the plus. All right, so now I have an algebra problem. It's a little bit complicated. First I had to distribute here. Now I have variables on both sides. Do you remember how to get the variables all on the same side? Yes. Subtract the entire term or add the entire term to both sides. Now I like my variables on the left and my constants on the right. So I'm going to do it this way. I'm going to subtract 5b to both sides of my problem. So I have 4b minus 5b. I'm taking away more than what's there, so my answer would be negative 1b. Now, I want to do the same thing with this 32. I don't want all of my variables and constants mixed up. So I'm going to add 32 to both sides. Remember, that's a minus 32, so that becomes 0. And I'm going to add 32 to this side. So 5, 6, 7, 3, and 4. So I now have negative b minus 0 is equal to 0 plus 47. So in this case, I can get rid of the zeros. What do I have left? I have negative b is equal to 47. Okay, that seems pretty simple. Now, I know you're probably thinking, okay, this looks like we're done here, but are we done? That's a good question. Isaiah, what do you think? You're right. We're not done. Why? Because in order to be a solution, the value of b cannot have a negative sign in front of it. Now, it could be negative. It could be like b equals negative something. But on the same side of the equal sign, it cannot have any sign in front of it. It has to have nothing there. And remember, nothing in algebra means an understood or an invisible one. Okay? So to get rid of that negative sign, I must isolate the b by opposite operation, divide by negative 1, and that cancels the negative sign and makes it positive to both sides of the equation. 47 divided by negative 1 is negative 47. There we go. So now I have my complete solution. B is equal to negative 47. Hope that was clear, and enjoy your learning today.